my lovely atoms. A very warm welcome to all of you. I'm hoping all of you are doing absolutely awesome and preparing for your exams properly. That exams are quite near, so your revision should be up to the par and it should be like going on a very fast speed nowadays because we did variety of videos just to help you all out. We started so much of series just to help you all out. We are done with Umang series, that is like concept building kind of a videos. We talked about each and every topic in detail. We started one short series with the help of the same. You do not have to study 4 to 5 videos of a chapter. You do not need to see those videos all together for a revision. You can see only one video for a complete chapter revision. Then we started VIP series and sprint series for your proper revision in terms of solving the different type of a question from sample paper and previous year papers and most probable questions with important topics, so that after seeing those videos this will be very helpful and you can easily score above 90. And here comes one more series, that is mind map series. There's already one video that's out, that is about is matter around us pure ninth class. Now this is the second video where we are doing structure of atom. The aim of this video is in about 40 to 45 minutes we are going to revise this chapter properly, but in a mind map, in a quick short notes way, so that you should know the important information, that you know the entire chapter, you're done with revision and you know that your exams are very near, suppose 1 day 2 day or so, and by seeing all those particular 3 to 4 videos you will be able to revise things at the same time. So be with me. I'm your Anubha ma'am, your chemistry master teacher at Vedantu, and stay till the end. We all are going to rock together and I'm pretty sure you all are going to do very much awesome. My blessings are with you. Okay, so let's start. I know the learning objective is crystal clear. We have to talk about structure of atom. Let's start right away. What you can see on the screen about cathode ray tube experiment, why exactly that was needed? You know that Dalton told us that atom cannot be divided further. Atom cannot be created nor be destroyed. Atom is something cannot be divided as well. It's not divisible. But here come so many scientists who disapproved by his theory, who disapproved his theory and told us, no, there are some subatomic particle that's there inside the atom too. And the one that got discovered in 1897 by J.J. Thomson is called as electron, also called as cathode ray. By an experiment that he ran is called as cathode ray tube experiment. You do not need to remember the entire experiment and all, but we should know the outcome, that he took an air inside it and any air at very much low pressure that will make the particle free, no pressure at all. They'll collide. When particles collide with each other, they start losing these electron only, and they were moving towards a oppositely charged electron. Electrodes are these metal rods that's connected to the battery. Negative terminal of battery, whatever the metal rod is connected, that's cathode. Positive terminal of battery, whatever is connected, is called as anode. So those negatively charged particles which were releasing by the air, it looks like that is coming from cathode because cathode had negative charge, that metal rod. And that was proved because they were going towards anode, which is positive charge. So it looks like something called as cathode rays, as they are having negative charges coming towards anode ray, because they were having a green color fluorescent effect, because these screen were painted with, coated with zinc sulfide, which is a fluorescent material, and with fluorescent material whenever any charged particle strikes it shines. So we got a green color fluorescent effect over there, which proved that there is some negatively charged particle, as opposite attract, they are coming towards positive and striking this wall. And that only we got to know about electron. You do not need to remember the experiment, but in that way we got to know about the electron, which is also called as cathode rays because it looked like something is coming from cathode. So this part is very much clear. Yes, students, you do not need to remember the entire detail, but you should know the basic process. So electron got discovered by J.J. Thomson by his theory, negatively charged particle, and how can we represent it as E minus? Minus is that negative charge, E is the electron. So the symbol of the same is this, and has negligible mass. That was also proved that its mass is very, very less, that we can neglect it overall atom is already so small that we can't even see by a good microscope, and inside it there are electrons which is having negligible mass, and charge already -1, but that's a relative charge we are talking about, that the charge is so less we consider this as a unity, and we are going to compare all the charges by that unity. There's like -2, -3, how much times with that charge, and the charge of that electron exactly is minus of 1.6 into 10 to the power -19 coulomb. Coulomb is the unit of charge, this coulomb, okay, and this they have considered as unity. So that's why it is relative charge, that each charge is equal to -1, okay, that this is 1 they consider, because every time 2 times 3 times it's so difficult to remember that. Yes, okay. Now after that, scientists were thinking, if negatively charged particles are there, there must be positive, because atom is neutral, atom does not carry any charge. So Goldstein, you can remember that, EGE. Goldstein give an experiment, e.g. Eugen Goldstein, Canal-Ray experiment. He just modified the same experiment by a slight detail. What was that? The cathode that we were taking, he just made it perforated. Perforated means he made holes in the cathode. Why? Because he told that if electron was negligible in mass, and they were traveling very fast, they could come and penetrate this anode side, and we are getting that fluorescent effect. But when it comes to proton, it is having comparatively higher mass. How much time? Almost 1837 times higher than the mass of electron. They are quite heavy. They won't able to penetrate, so that we can also get a glow on this side, so that we can say that some positively charged particles are also there. Why on this side? Because cathode is negative, positive will come towards negative only, na? So after those air particle losing its electron, left with positive charge, they start moving towards cathode having negative charge, but they can't pass because they were heavy. When we made it perforated, they were passing and making this part green also, which proved that positive charge particles are also there inside the atom. We nowadays call it proton, but that time that was called as anode ray as well, because anode get a positive charge and it looks like something is coming from positive as it's approaching towards negative. So my proton earlier was called as anode rays, also as canal rays, because those stream of particles looked like a canal. Okay, you know that. So that's other different name of your proton, you should know that. And important points was similar experiment, but you know that we just made some changes in the same experiment, and we got our proton with positive charge, and the charge is equal to electron too, because atom is neutral. The charge on proton and charge on electron is same, that's why they get cancelled and we get neutral atom. And mass in NCERT it's written 2000 times, because they're like, let's just give an approx value, that is 1837 times. You can remember both way, that will work only, that mass of proton is 1837 or 2000 times of mass of electron. Okay, you can remember this is important. And now, how to represent it? Definitely P positive, P for proton, and positive means its charge. And these are the exact value. As you understand that the charge of electron and proton is 1.6 into 10 to the power -19 coulomb. It's just the sign is different. That's the exact charge when it comes to relative, -1 on electron, +1 on proton. Because that one unity is representing that exact charge, and for our convenience we are using that as a unity. Okay, it's just we made the scale and we can have some changes accordingly according to our convenience. And when it comes to mass, we just told that electrons mass negligible, but exactly that value is 9.1 into 10 to the power -31 kg, which is quite small, very much small, I must say. And when it comes to mass of proton, that is which is almost 1837 times or 2000 times, that is exactly 1.66 into 10 to the power -27 kilogram. You got this point? And this difference is quite big because atom itself is very small and very, lightweight. Okay? Now the point is, when electron and proton got discovered, we could talk about the neutrality of atom, but the mass was not justified. There was something that was still missing. Scientists got an idea, because when they calculated the mass, and compared the mass of the sum of proton and electron, there were a big difference. Let me tell you an example. When it comes to carbon, carbon had 6 proton and 6 electron. And how to calculate its mass? Mass, for the convenience of one proton, we consider it as 1 unit. Okay, 6 proton, 6 unit. And electron mass we consider negligible. That means 0. The mass should be 6 unit. But when scientists got the value of mass experimentally, the mass of carbon came out as 12U. Like there is a still difference of 6U. So he thought, who? James Chadwick in 1932, that there is still one particle that's missing inside the atom that must not carry any charge because charge is already satisfied, but carry mass almost equal to your proton. And that, was whole true. He proved it only. So that comes the discovery of neutron, which is neutral particle carrying no charge but mass almost equal to proton. That is 1U. In short, we can say that. And how to represent it? N0. Charge on neutron is 0. This is electron, this is proton, and this is neutron. So please remember these details. These are quite important. All right. Now, before moving ahead, let me just tell you, you must be thinking, most of you are done with your exams. Some of you might be having your exams. And you're thinking that, ma'am, what to do next? How can we be a part of Vedantu? And let me tell you what Vedantu is offering to you, everyone. That at this platform, if you're done with your 9th class and wanted to go for 10th class and wanted to study everything in a beautiful manner, in all the live class with all the amazing teachers that we have, in each and every session there will be plenty of quizzes to make sure you got the topic, because that will be active learning. You will also participate. It's not only the teachers. We'll just done with the topic, we'll take a quiz of the same topic to know that you got it. Okay, and you'll see amazing leaderboard also, that how many of you are giving how many correct answer and all. And definitely you will be able to compete with the students throughout the world with different diversity, and you will be able to learn amazing things from each other as well. You see a change in your personality. Interactive replays to students, it's not something that will be super bored that, oof, I have to see the replay because I missed a session due to some reason. You won't get the feeling. You'll be like, oh, that's fun because that's a good way of revision. You'll be able to play quizzes which were not happening anywhere, live quizzes, and you can come to leaderboard. Isn't it an amazing thing? That can happen for sure. You will be able to download the content of each and every session. So whatever we teach with our own feedback, this is important. These are the questions you should not miss and everything, so that you'll not only do hard work but will be smart as well. You'll be able to revise thoroughly with the help of those notes. You'll easily get it on one click, that I'll tell you very soon. And not like, ma'am, what's the use? We'll be sitting, and if we come across with any doubt, how I'll be able to ask the doubt, because I feel a bit shy to ask the doubt and all. So students, in every session there'll be a Q&A panel, question and answer panel, where there'll be a team of amazing class teachers who are going to be subject expert only. With them you can ask your doubt without any hesitation, because every doubt is important. So even teachers and class teachers will take your doubt. You will get test in every 15 days, so that you won't forget the things, because that is a cycle, right? If you won't revise things in 21 days, you might forget that. That won't happen. Variety of assignments with the plenty of questions, so that you won't get the feeling that I don't know, that question is not a part of syllabus or something, because you might not read that in that manner. Every revision with plenty of chapter based courses, micro courses, and special courses also, special modular courses, to make sure that will add up in your journey of academics and will give you amazing results. And crash courses for quick revision as well, midterm revision as well. So you are going to have an awesome journey at Vedantu in a very less price. Let me tell you, there is a link in the description box. Just click on it and select AG Pro code, and you'll be able to see this category. You'll get 2 options, 1 month session and till March 2022. So you can take 1 month subscription as well as the entire year subscription. But you know that more the time you're going to spend, more benefit you're going to receive in terms of, monetary benefit. If I talk about pro price, pro means that's not a revision. Entire facilities will be for 2700 for a month for 10th class. But if you'll apply the code that I showed you, AG Pro, AGE Pro, the same course will be for 2160. But for an entire year, entire 10th class, the price will be 32,399, and that will decrease to 25,909, and that will be definitely a difference that you can see. Each and every session in 12 rupees, each and every session in 10 rupees. You see the benefit, and obviously more time you're going to spend, more benefits you can get over there with time, and amazing teachers will teach you definitely. So in case of any problem, that should not be a problem. Let me tell you how to do that. And I have taken you to one of the video of 9th English channel. See, this my video only, tips and tricks of remembering color of compounds. You will find a link over there. Okay, let me see that. And yes, subscribe to Vedantu Pro now. Click on this link and select you want to move to 10th class and target CBSE 2022, right? Next academic year. See, 1 month and March subscription you're going to get. Proceed to pay. This is what you need to follow. And as soon as you're going to apply the coupon code here, apply. See this, the price will decrease. It will be further decreased. Just see the videos, that is the fresh one, because that's a bit previous one. But right now the price will be as shown by me before. Let me show it again to you. That is 2160. It's just further reduced as well. Okay, so don't worry, you will get all the benefit. Like, this is kind of a my session list you're going to receive. You will be able to see your upcoming session from here in my session list. Here, by past session, you can see all the sessions replay and can get notes of each and every session, detailed notes, and there you will get an idea that how every doubts here is solved. See, you will be able to see the replay, and not even replay, you will be to the entire page and will get so many benefits, like all the doubts get solved and entire data of the class also. Okay, so it is going to be a wonderful experience. Don't miss this. I have guided you properly because that was necessary. Let's just be back on our slides. Let me make myself on the entire screen. Yup, students, so you know everything now. And I hope you are liking the video and sharing it to your friends and subscribing to the channel also. Because if you do so, what will happen? The thing is, you will get each and every video notification in advance so that you won't miss it. So students, get the maximum benefit because this will be amazing. Okay, let's move ahead now. Let's talk about, okay, there are two codes that you can apply, AG Pro or AGE Pro, both will work. AG Pro for the 9th channel, this is for English channel. Both are same only, for me only. Okay, now here comes to this topic that when electron, proton, neutron got discovered very late. When they were discovering, scientists got an idea that atom is having these things inside it, so they must be properly placed. So how they are exactly placed, what will be like atomic models, how they are placed, that were told by different scientists. So the very first atomic model was given by Thomson, called as Thomson's atomic model. And I think he loved food too much. I do think so, because he called his model as plum pudding model, watermelon model. So he'll be like, just like a plum pudding model, plums, dried plums are embedded, and this floor and everything is just like a positive sphere. I mean, a sphere. In the same way, atom is also a sphere of positive charge, just like this floor and everything. And just like dried plums are embedded, in the same way, electrons are embedded inside the atoms in such a way that the total magnitude of positive charge is equal to total magnitude of negative charge, and we can say that atom is neutral. Same with the watermelon, that my atom looks like a watermelon, and the red part, the edible red part, is representing the entire positive charge on the atom. And just like seeds are embedded, in the same way electrons are embedded inside it. That's how atom looks like. But there are so many scientists who disapproved it, that atom is not entirely carrying a positive charge, because some of the scientists, the very first one was my Rutherford only, who disapproved this model. Okay, so here comes so many problems. So as I said, Rutherford came with this experiment called as gold foil experiment, also called as alpha particle scattering experiment. He took a source of alpha particle. I hope you remember, because you are done with the chapter. And scatter those alpha particle on a gold foil. Why he chose gold foil? Because that's very thin, that's maximum malleable, you can make a very thin sheet out of it, and very thin, like more of like 1,000 atom, because he were passing alpha particle, which is helium plus 2 particle with plus 2 charge and 4 unit mass. 4 unit mass due to 2 proton and 2 neutron inside the nucleus. Nucleus carry proton and neutron. Every proton 1 unit, every neutron 1 unit. In total 4 unit mass. So he discovered alpha particle, which is just helium nucleus carrying proton and neutron, no electron, on the gold foil, and just got the result on the screen. In what way? He took a circular zinc sulfide screen, so that every time when these alpha particle, because of very fast moving, penetrate this thin gold foil, I can get shine on the screen, because every time when charged particles strike on such screen, you show scintillation shine. And that was, connected to a monitor, so that every time when there is scintillation, those shine, that can be calculated, like per second how much atoms are striking and all. So it was found that most of the alpha particle are deflected and pass straight only because most of the space of the atom is empty. Okay, those alpha particle could pass properly. When it comes to my second thing, that most of the alpha particle passed, but some shows a deflection also. Deflection means they were just deflected in some other direction. That's only because the entire charge of the atom is centered at the center, and when alpha particle carrying plus 2 charge is approaching towards it, near it, plus plus repel each other, positive positive, same charge repel each other, and they show deflection, means entire positive charge is there in a very tiny volume, and 1 out of 12,000 just deflected its in the same direction, like rebound its path. Only 1 out of 12,000 rebounded its path only when there is a head-to-head collision. Just consider the entire mass centered at the atom, more of like a ball, because that has mass. When you throw a ball, that comes back. In the same way, when you threw helium plus 2 particle having 4 unit mass, enough mass on this, more of like a ball, it has to come back. So when these helium plus 2 particles just directly approaching to the entire mass of the atom, they come back. So they say, who said? Rutherford said that the entire mass and entire positive charge lies in the atom in a very tiny volume, and he called that part as nucleus of the atom and got the Nobel Prize for the same. Isn't he the awesome one? Yeah, he got Nobel Prize for the same, for the discovery of nucleus having proton and neutron. And he'll be like, these electrons are just rotating around the nucleus. Okay, just like a planetary model, just like Earth rotates around the sun. But he couldn't elaborate it properly. He did great work, but one thing, that when he talked about electron, he just didn't comment much. And we know that whenever any charged particle rotates, it accelerates, it changes its speed, and can finally come closer to nucleus and can fall to nucleus, which doesn't make sense because atom won't be stable at all. For stability, there must be a proper way to arrange the proton, neutron and electron. Here, electron possibility is not proper, stability of atom is not proper. Then who comes to our rescue students? All of the properties are written. For the rescue comes our Niels Bohr. Okay, so conclusion is written of the model. And let's reach to the Niels Bohr. We know the drawback also. So I'm just taking to the next part. Niels Bohr just overcame the problem that was faced by Rutherford, that whenever charged particle rotates and all. So Niels Bohr told, whenever any charged particle rotates, it has to rotate in some circular path which is having fixed energy. So how electron can change its energy when they kept on rotating in a same energy circular path? These energy circular paths are called as orbit or shell, or you can also call it energy level. That when electron has to rotate, they always rotate in a fixed energy path. Okay, these circular orbit are called circular path is called as orbit or shell. Yeah, so when electron rotates in the same, it kept on rotating in the same orbit without losing its energy at all. It's just when energy is given from outside, it's like, I have water, I have heated it. So water is made up of particles, right? Atoms and molecules, whatever it is. When we heat it, those particles are getting energy, right? And they're try to move, they try to, excite. So that happens to electron also. They get enough energy, and when we move to next and next orbit, energy is getting increased. They can jump to higher orbit of higher energy, but he will feel so alienated because that didn't belong to the same. So it will come back by losing the extra energy. So, excuse me, the gain of energy and move to higher orbit, and loss of energy and move back to its lower orbit, energy orbit, is possible only when outside energy is responsible. Otherwise it will kept on rotating with the same speed, which is a better theory to understand, isn't it? So that's what the model, a good model comparatively, so please remember that advantageous one. Yeah, that how these shells are there. These have some special names also. Rather than the first shell, second shell, third shell, fourth shell, he gave the name like K shell, L shell, M shell, N shell, and so on. KLMN. Like, why not ABCD? Because I think he's bored of ABCD. No, exactly, because ABCD are some of the other coefficient we generally use in chemistry so many times just to make a difference, and that too capital one. Okay. Now, after that, we should know a very important concept called as valency, because that helps to know how the atoms are going to combine. And valency and valence electron is again very helpful. We should know the electronic configuration, we should know the valency, because these are important ones. How to write electronic configuration? What exactly is electronic configuration, students? The electron that is going to be present in different shells, we show it properly. That's the electronic configuration. The presence of electron in different shell that we are showing, and that was given by Niels Bohr and J.B. Bury by a rule called as 2n square rule, how the electrons are going to be there in different orbit. So n is the number of orbit here. So the very first orbit, 2 1 square, second orbit, 2 2 square, and so on. So first orbit is going to have 2 electrons, second 8, 13, 18, and so on. That's how electrons are present in different orbit. Okay, when we know electronic configuration, I can tell you about valence electron, because valence electron is the electron present in the last shell of the orbit. Last shell means the shell in which the last electron of the element goes. That's it. That if you know, you can calculate valency too. The electron present in outermost shell of atom is called as valence electron. Suppose I'm talking about sodium. 11 is the atomic number. Atomic number is what, students? The number of proton in the atom, which is a unique property, which how we show it, we write the symbol at the bottom, we shows that atomic number. We call atomic number as Z or Z. And whatever the number of proton, that's also electron. So if that represent proton, electron will also be same, because atom is neutral. So 11 electron, how will I write according to this rule? 2, 8, 1, right? First is having a capacity of only 2. Second 8. We are left with 1 electron that goes to next shell. So this is valence electron. Electron present in the last shell. Simple. Okay. And how to calculate valency? First of all, what is valency? Is the combining capacity. How my atom is going to combine with the other atoms. And why it has to combine? Just to feel stable. Just to have a proper stability by following its octet or duplet rule. Octet rule for all this shell except one which follow duplet rule. Octet means 8 electron rule, duplet means 2 electron rule. First shell is just having a capacity of 2 electron, so it will follow duplet. Do comes from 2. Rest, all the shell will be stable if they have 8 electron. So just to have that stable configuration, atom has to lose, to gain, and to share electron with each other so that it will feel stable. That's what the valency, how many electron lost, gain or share. That's the combining capacity, how an atom is going to combine with the other atom. For the same, just remember this rule. If valence electron is 1 to 4, easy way to calculate it. Valence electron 1 to 4, valency is equal to valence electron. If valence electron more than 4, then what will happen? My valency is 8 minus valence electron. If 5 valence electron, so just to complete octet, it will gain 3 electron, valency 3. The other way, 8 minus 5, 3. In that way, 3 valency, 3 electron, it believes in losing 3 electrons so that the last shell will follow octet. So valency 3. So that's the combining capacity only. right? I told you what is atomic number, that represent by Z, number of proton also equal to number of electron. Mass number we represent by A, students. With what? A. And that's the sum. You know that mass is responsible due to proton and neutron, not electron at all. So this is the sum of proton and neutron responsible for the entire mass. And how to represent the element, like we'll get the proper information about the atom, that's in this way. How to pronounce it? ZXA or ZXA. Okay, first we'll call the atomic number, then symbol, then the mass number. Atomic number Z, X the symbol, A is the mass number, which is sum of proton and neutron. Why proton I wrote by Z? Because proton is the atomic number 2, and Z your number of proton or atomic number. Do remember, from the proton and neutron, if I remove the proton, I'll get with neutron, right? So A minus Z is, neutron and proton, minus proton, cancel, is the number of neutron. Okay, so A minus Z gives the number of neutron. Some questions can come from this topic to calculate number of neutron when this data is given. So do focus on that point. Now, from this topic also, so many times question came, that is, what is isotope? So students, iso itself means same. Okay, what exactly is isotope? When you have same element, all of its atom can never get the same mass, because most of the atom, even of a same element, can carry different mass due to different number of neutron. Proton is same, but there were no deal about neutron. So in a nucleus, proton same, okay? But if neutron is differing in the cases, then what will happen? Those elements will carry different mass. That's what the isotope. Same element, atom, different mass. Just like chlorine, 35 and 37. Mass, how the mass is changing? When the atomic number is same. Why atomic number is same? Same element, same atomic number. Because their neutron is changing, which is having mass as well. 18 neutron, 20 neutron. Neutron is changing. That means the same element can carry different masses. Three more example, like same example with three isotope. Hydrogen, 1H1, 1H2, 1H3 is called as protium, deuterium, due for 2, tritium, tri for 3. Here, just because of number of neutron changes, 0, 1, 2, we got this, that we got three isotope of hydrogen. Okay, students, these are some important points that you should know about isotope. The number one, element, whenever I take an element that is going to have a mixture of isotope. Suppose I'm taking a sample of chlorine, and you know what? 3/4 of the chlorine will be having the mass of 35 unit, and one-fourth part is having a mass of 37 unit. Whenever you take an element that is having a mixture of isotope, same element with different masses. Each isotope is pure substance because each isotope, suppose chlorine 35, all the atoms are same only with the same mass, same chemical property. So each isotope is definitely follow pure substances property because that's pure in nature, made up of same particle. Okay, and its chemical properties are same because chemical property depend upon the element and its valence electron. If element is same, its valence electron are same, so chemical property is same, like how it's going to react with the other substance. But physical property are going to differ because physical property is mass dependent. As mass is changing, so as physical property. 35, 37. 1H1, 1H2, 1H3. Carbon, C12, C13, C14. Mass is changing, so as physical property. Okay. Now the point is, ma'am, if I talk about chlorine also, there are two isotopes. What mass I will choose? What will be its average mass? So how to calculate average mass? It's not like 35, 37 by 2. We have to take its abundance into consideration also. Abundance means in nature how much amount it's having, how much percentage it's having. Because if someone is in high amount, if some elements isotope is in more amount than the other, that will contribute more for the mass, right? So I have to take this formula, that summation, this is summation sign, that whatever the isotope is, suppose I'm talking about chlorine only, 35 and 37, how to calculate that, students? Mass of the first one, mass of whatever the involved isotope, into its abundance. Mass of second one into its abundance, and so on. Divided by total abundance. If we are taking percentage, total percentage is always 100. So 100. So we kept on adding this, whatever the number of isotope are there, and here the summation is for the total abundance. If that's in percentage, it's always 100. Mass of the first isotope, abundance. Mass of second, abundance. This is just like this one, 75% abundance, just this one, 25% abundance. You can put it total abundance 100 and you can solve it. You have the masses, you have the abundance, and I have solved that as well in the previous videos. Okay. Now, these isotopes are very much important, especially talking about the radioactive isotopes. What exactly are radioactive isotopes, students? Radiation active means there are so many isotopes having excessive number of neutron. When your neutron and proton ratio of an element, neutron is comparatively higher than proton, and so that its ratio is more than 1.5, such nucleus are not that stable and will be radioactive in nature, means continuously emitting radiations. And some of them are having some medicinal property uses as well, just like uranium isotope 235 mass will carry as a fuel in the nuclear reactor. Cobalt with 60 mass is used for the treatment of cancer to detect the tumor as well. Iodine carrying 131 mass is used for the treatment of goiter. You know, the swollen neck, that thing. Okay. Now here comes what is isobar. Again, iso is same, bar is mass. Students, these two are very much important. Please do remember that. There is one more thing, isotones. What is isotone? Iso means same, tone means neutron. So there's one technique you can use, that is PAN. Okay, when I write isotopes, write it properly, isobars and isotones. What exactly I saw, let me just have you ate a pans like one or the other moment of time in your life. Again, so just see the last third letter. P, last third A, last third N. Isotopes, same P, same proton. Same proton means same atomic number. What's going to differ? Mass. A stands for, see third letter. A stands for mass. I told you already. So same mass. This means that thing is same. Same mass, so what is going to differ? Proton number. N is same. N is what? Neutron. Same neutron. So you can remember this technique too. So what is isobar? Same mass but different element. Okay, different element carrying same mass. Just like argon, which is a gas having a mass of 40 unit, and calcium, solid metal but having a mass of 40 unit. These are isobar. Do let me know its property in the comment sections. What are the property that isobars are going to follow? I'll wait for your comments because homework is very much important. Please do that. Okay, this will be wonderful. So students, what happened, our structure of atom revision is done properly with some of the short notes, and you can use it as your quick revision. This is going to be very helpful. Do let me know in the comment section. I'll wait for your comments. Don't forget to like the video because if you do so, it will reach to more masses and they'll get to know about this platform. They'll be able to get the education that they needed. And don't forget to subscribe to the channel because subscription, if you do, you won't miss any video. And don't forget to share it among your friends. Okay, students? And you can join Vedantu Pro classes in a wonderful price, that too with AG Pro code. That will be just like around 12 rupees per session and 10 rupees per session. If you take it for an entire year, Vedantu will be there and you can come back right now also. So don't miss those opportunities. Okay. You can follow me on Insta also. Finally, Vedantu_Anubha. That's amazing. Okay. So thank you so much, students. We'll meet next time. Until then, keep learning, keep following, keep spreading the happiness, do the good work. Thank you so much. Tara, take care.